All right, here we are on section 10.4 on operations on radical expressions. So our objectives are adding and subtracting radical expressions, multiplying radical expressions, and finally rationalizing the denominator. Radicals. So like radicals have the same index, the nth root power, whatever you want to call it. It's, whatever in this case, it's a square root. If we had a 2 here and a 2 here, that's the same index. And they have the same radicand, indicating, both of them are square root of 2, square root of 2, square root of 2. Unlike the square root of 2, it's the square root of 3. So these are like, so it has to do that. And these are unlike, so we can't do that one. Okay, so that's the key. So if possible, we're supposed to add add the expressions and then simplify. So first off, are they the same? Well, we have 2 and a 2, 7 through 7, or a 7 and a 7. So it looks like we could just add across and get 12 squared is 7. Here we have a 3 and a 3, so same index, 5 and 5, same radicand underneath. And so we just add and we get 9, so cube root of 5. Now this one, we don't have anything we can do because this one doesn't have a square root of 13. And so this is just as far as we can go. So we can't do anything with this one. So they can't be added. And this one, same thing. We can't add those two. Okay. So because of that, we're basically done at that point in time. Now here we're supposed to write each pair of terms as like radicals if possible. Well, we have a square root of 80, square root of 125, and 4 times the cube root of 16 times 7 cube root of 54. All right. So 80, well, okay, it's already moving on, but that's okay. So that's going to be what? Well, that's 16 times 5. Well, square root of 16 is 4, so it's 4 square root of 5. Well, what's 125? Well, that's going to be 25 times 5, so it's going to be 5 square root of 5. So now we have them in the same uh, basically typed of radical, the square root of 5. Now we can take, if we want to add them, we have 9 square root of 5, subtract them, depending on which one they want to say 4 square root of 5 minus 5 square root of 5, so it'd be a minus square root of 5, and so that's what we could do there. Now what about this one? Well, this one we can break down into 4 times the cube root of 8 times the cube root of 2. And so then we could simplify this. And so that's going to be 4 times 2, because there's going to be 2 here after you take the cube root, and then times this. So that's going to be 8 cube root of 2. Now, can we figure out how to get that one to a square root or a cube root of 2? Well, that's going to be 27 times the cube root of 2. Cube root of this is going to be 3, so 3 times 7 is 21. So we'll have 21 cube root of 2. And so then again, we have the same index and radicand. Okay. Here we're supposed to add the expressions and simplify. Well, okay, well, what is this? Well, 20, we can do 4 and 5, and square root of 4 is 2, so 2 square root of 5 plus 5 square root of 5. And that shows here, when we keep going, that gives us 7 square root of 5. Here we have to break this down and see what we can do. So we have 5 square root of 2. That's nothing we can do there. And then this one's going to be what? 25 times 2. So that's going to be 5 square root of 2. And then this one, oops. And so then this one is going to be, so we can break that down into 36 times 2. So that's going to be 6 square root of 2. So we have 5, and then 5 and 6. And then we add all this together, we get 16 square root of 2. Okay. And again, if you go and you like on this one here, if we did like we did on a previous video, we did 8 and 9, and then we broke the 8 down into 2 and 4, and then we had the 2 times the 3, which gave us the 6, and then still a square root of 2, we could do that. Or since I remembered we had 36 before, then we could do 36 times 2 and get that one directly. Okay. All right, let's stop there and come back for some more.